Hi, welcome to Imperium Learning. The topic of this video is going to be how to estimate a vector error correction model on Eviews, and after that how to interpret the results. So let's just go on to Eviews now, and let's click on Quick, and let's estimate a vector error correction model. Now actually, bear in mind that I have a total of 6 variables, and of these 6, so I have 6 variables. I have the interest rate, I have the average house price, that's my key dependent variable, I have Lun credit, I have Lun GDP, I have the money supply, which is Lun M4, and finally I have the unemployment rate. Now, it's in case you haven't seen any of the previous videos, I found that 5 of my variables contained a unit root, but the one that didn't was my Lun GDP variable. And I just want to graph this just so that you can see it. This doesn't contain a unit root. Instead, this appears to be what's known as a trend stationary process. Now the thing is, when we estimate a vector error correction model, we could put our unit root processes in here, and we could actually put the Lun GDP variable in here, in the exogenous variables. But we can't just put it in the way that it is. Instead, what we'll need to do is we'll need to create a residual series. And in order to do this, we're going to have to try and detrend this DGP so that it's essentially a zero mean process, a zero mean stationary process. So what we could first try to do, in order to do this, we will probably need to create a dummy variable to account for the structural break. And so what I've done is I have a nice little format to create a dummy variable. Whenever you want to create a series, let's say you wanted to create a dummy variable, the first thing you always type in the command box is series. That's what we want to do to create a new series. I'm just going to right click this very quickly. Again, the Eviews website has some good PowerPoint tutorials on in the help section of their website to show you how to code a dummy variable. So if you want to learn more about dummy variables, because there's more than one way to code a dummy variable, go onto their website and take a look at that. This, however, is one way that we can do it by using what's called the @recode function. And so essentially the format of it is that you set out a criterion, and if your variable satisfies that criterion, if it's true, then it takes the value in this section, and then finally, if it's not true, it takes the value 0 when it doesn't satisfy the criterion. So in this particular, I mean, let's just take a look at my let's take a look at my Lun GDP variable very quickly. If you can see, it seems like the structural break almost starts there, right? And we could argue it carries on until something like here. Something like, say, the 3rd, let's say March of 2009. So actually, let's just change the... Actually, for now, I'm just going to leave it just to I'm just going to leave it. But suffice to say that this is how we would create a dummy variable. It's quite complicated, but again, I'd advise you to check this stuff out on the help section of the Eviews website. And so what we want to do in order to, the first way that we could possibly try and detrend our trend stationary process is to do a least squares regression, where we regress our dependent variable, this is our dependent variable, ln GDP, on a constant, on a time trend, because bear in mind that the data generation process, it appears as if it's a function of time. And then finally we could just put in our dummy like this. And we could actually use the Newey West estimators to try and avoid heteroscedasticity and serial correlation. And then finally we click OK. Now the first thing we want to do, and we can see that all of these are significant because they all have p-values that are below 0.05, if you see where I'm highlighting. The first thing we want to do is we want to look at the residuals that are in this equation. So what we do is we look on here, we click on view, we click on actual fitted residual, and then we click on residual graph. Now as you can see, this really isn't an ideal residual graph to have. It doesn't really look like it's properly detrended our ln GDP variable. As you can see, it's starting quite far away from 0. It crosses 0 and then it converges away from it for a very long time. Of course, then there's this huge fall there, which coincides with the global financial crisis, and then it crosses 0 and then it kind of trends downwards again. So this is quite a concerning thing, because the residual graph is still what we should really be seeing is a process where it's regularly zigzagging across 0. That's what we should really be seeing, so that we know that we have a stationary 0 mean process, right? It should just be regularly crossing the 0, and it doesn't do that. It crosses it very rarely, and it swings away from 0 for a sustained period of time. So that's not really an ideal way of estimating a dummy variable. So what we can do instead is we can close this, and we can go click on quick, click on estimate equation, and what we're going to do now is we're going to estimate a least squares with breakpoint regression. Now I can actually see that I'm approaching the 10-minute. We're still over a minute away from the 10-minute mark, but I think this is gonna, I want to analyze this properly to ensure that viewers really understand it. So I'm going to wrap up the video here, and I'm going to talk more about how we estimate a dummy variable, or how we detrend a trend stationary process in the proper way. Okay, bye now.